So this video is on square root function. General equation y is equal to a times the square root of x minus h plus k. A is our stretch. Whatever makes our square root underneath the square root a 0, whatever h is that makes this a 0 is going to be the x-coordinate of your vertex. Your k is going to be the y-intercept of your vertex, or I should say starting point, locator point. So if I'm going to do a basic y equals square root of x, what we need to remember is you can't take the square root of a negative. The square root of a negative is an imaginary number. So what that means, if I'm trying to put in the square root of 5, the square root of 2, the square root of 1, all of those are going to be undefined for this. So my very first value that I can put in here is the square root of 0. So I'm going to go through and take the square root of 0. Okay, so the square root of 0 is 0. So I'm going to have my starting point at 0, 0. Again, the square root of a negative 1 would be an imaginary number. Square root of a negative 2 would be an imaginary number. All of these negatives would, when underneath the square root, give me an imaginary number. So when I go over 1, the square root of 1 is 1. Now, I could take the square root of 2, but it's going to be a decimal. Square root of 3. I'm going to try the square root of 4. Square root of 4 is 2. So I'm only going to take the square root of the nice perfect squares, so I have nice values to plot. So then square root of 0, square root of 1, square root of 4, square root of 9, and the square root of 9 is 3. So I'm going to go up to 9, 3. My next nice one would be 16, which would be 4, and 25, which would be 5, and so forth. So now I'm going to draw it as a curve, and you're going to see that this looks like half of a sideways parabola, because it actually is half of a sideways parabola, because the inverse of y equal x squared is x equal y squared. And if I was, and that would be this whole entire parabola on its side. But when I am trying to get this in y and x equal form, I'm going to square root both sides. So this is going to be the square root of x. And when I square root something, I always get a positive and a negative. And so I honestly would be getting a positive root, which we call the principal root, which is the one that I drew here. And then a different graph would be the negative. So we're focused on the positive root. Okay, that's the one we're focused on. So this one right here would be y is equal to the square root of x. Now, when I'm looking at these, you'll notice that these all look similar. This one is just the square root of x, which is the one I just graphed. This one is a negative square root of x, which is going to flip this across the x-axis. When I put a negative in here, what happens is the x's that were positive, the results I got for my positive x's, I'm now going to get for my negative x's. So it's going to flip it across the y-axis. And then a negative in front of a negative square root is going to actually flip this one here to across the y-axis. So let me graph these ones real quick. So for this one here, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And that would be my positive square root of x. Now, this one here, I'm going to be getting the same results when I take the square root of 1 and 4 and 9, but then I'm going to times it by a negative. So the square root of 0 is 0, but 0 times a negative is still 0. Square root of 1 is 1, but when I times it by a negative, I get a negative 1. Square root of 4 is 2, but when I times it by a negative, I get a negative 2. And square root of 9 is 3, and when I times that by a negative, I get a negative 3. And so that would be my negative square root of x. So you see how I'm getting a sideways parabola. This would be the positive root. This would be the negative root. Now, remember how I said you cannot take the square root of a negative. So if I was to put a 1 in here, positive 1, I would be having the square root of a negative positive 1. So that would be really when I put a 1 in here. So this negative actually makes whatever my x is opposite. So if I'm trying to put in a 1, I'm actually making this into a negative 1, and I cannot take the square root of negatives. So all of these positive x's, when I put them into this, are going to become negatives, and I cannot take the square root of them. But when I put a negative in, the opposite of a negative is a positive, or a negative times a negative 1, for example, is going to be a positive. So it's going to flip it to the left. So the square root of 0, well, so a negative 0 is still a 0. Square root of 0 is 0. The square root of a negative 1 becomes the square root of a positive 1. So I have 1. When I put in a negative 4, I'm really taking the square root of a positive 4, which is going to give me a 2. When I put in a negative 9, the square root of a negative 9 is the square root of 9, which is a 3. And so you see that I'm getting this, instead of opening to the right, it's going to open to the left. And then my last one is going to really just be taking this graph I just did here, all the same results. And again, I have a negative underneath, so I can only be putting in the negatives because that's going to actually make this positive. The positive values would keep this as a negative, and I cannot take the square root of a negative. So square root of a negative 0 is really just a square root of 0. And if I times it by a negative, it's still 0. So that one's going to stay. And again, when I put in a negative 1, I'm now really making it a positive 1. And the square root of positive 1 is 1, but I have the negative out front. So it makes it negative. So negative 4, you'll see it's going to come down here to a negative 2. When I put in a negative 9, I'm really taking the square root of a 9, but I'm timesing it by a negative afterwards, so that's going to make it a negative 3. And that is our negative square root of a negative x. Now, this graph here, I'm going to identify my starting point. So my starting point is going to be what makes this 0, which is going to be a negative 5. So this is going to be a negative 5, comma, this plus 4. So I am going to be starting at, I'm going to be starting at negative 5, comma, 4. Okay, so let me start there. And just change this. Okay. So I'm going to go to negative 5, comma, 4. That's going to be my first point. And this is where I'm going to start doing my square root. It's just a basic square root. So from here, I'm going to go out 1. Square root of 1 is 1. From here, from the starting point, I'm going to go out 1, 2, 3, 4. And the square root of 4 is 2. So I'm going to go 2 up from the starting height. I'm going to go out 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. 1, 2, 3. And I don't know if I can go 16, maybe. See, 9, 10, 11, 12, 13, 14, 15, 16 would be off, but I would have gone up 1, 2, 3, 4, and this would be our graph. Now, the next graph that I'm going to do, I have a negative 2 in front of it. So I am going to take the square root, and then whatever answer I get, I'm going to be timesing it by this -2. So my locator point, or my starting point, is going to be what makes this 0, which is going to be a -1, comma, 8. That's where I'm going to start at. And then once I start there, okay, so -1 comma 8, from here, I am going to draw a square root graph with a stretch of a -2. So when I go out 1, square root of 1 is 1, but I'm going to times it by a -2, so I'm going to go down 2. I'm going to go out 4 now. 1, 2, 3, 4. Square root of 4 is 2, times my -2 is going to be a -4. 1, 2, 3, 4. Okay, from the starting point, I'm going to go out 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The square root of 9 is 3, times it by that -2. I'm going to go -6. So 1, 2, 3, 4, 5, 6. So because it has a negative in front, it's going to be flipped where it's going down instead of going up. And if I wanted to just double check any value, just to understand that if I was making a table, I could be substituting in numbers. Let's say this point here, 3, comma 4. If I put a 3 into that equation, I would have y is equal to -2 times the square root of 3 plus 1. See, I'm going to get a 4 underneath that. The square root of 4 is going to be a 2. And then I'm going to have a -4 when I do that math, plus 8, which is going to give me a 4. So you see that I have a 3 that I put in. Okay, so I put in a 3, and I'm getting out a 4, which is the point that I had. And I got the same value without doing a table. Okay, now the last one, I switched it up here. I have a +3 as a stretch, so I'll be timesing by 3. But notice I have a negative here. So remember, my square roots, plain square roots, should be going like this. My negative in front of a square root is going to go down like this. But if I have a negative in front of my x in my square root, it's going to make it go to the left. Okay, so that's where my graph should be going. Now, this is where you have to be a little careful. When you're doing this, you want to think what is going to make what's underneath the square root 0. So understand that -x is affecting that. Okay, so if I was to set that equal to 0, I personally would add my x to the other side, and I get that my x is a 4. Okay, so you got to be careful when you see that +4. It's not going to be a -4 because of the negative in front of our x. So this is going to be 4, comma, -7. That's going to be where I'm going to start. So I'm going to go to 4, -7, 4, -7. Now, remember, the reason it's going to be going to the left is because if I was to put 5 into this, if I was to put 5 in here, I get a -5 plus 4. That's going to be a -1. So I cannot take the square of a negative. So that's why this is going to be my furthest point, and everything else is going to go this direction. So if I, since I was putting a -5, I mean a 5 in here, it made this a -5. I can't go that direction. So if I go this direction, I put a 3. A -3 plus 4 is a 1. And the square root of 1 is something I can take. So it is going to be going this direction. And when I go one away, that's how I'm getting that one in here, because when I put in a 3, -3 plus 4 is a 1. So if I understand that I am just taking square roots of numbers from my starting point, I'm always going to be doing this correctly. I just need to make sure I pay attention to if it's a negative in front of the x, if it's a negative outside of the square root. So when I come over here one away, okay, really I'm at -1 from it. The square root of 1 is 1. I'm going to times it by 3. So I'm going to go 1, 2, 3. When I go out 1, 2, 3, 4, the square root of 4 is 2. And I'm going to times that by 3. I'm going to go 1, 2, 3, 4, 5, 6. When I go out 1, 2, 3, 4, 5, 6, 7, 8, 9, the square root of 9 is 3. And 3 times 3 is 9. So this is, I'm down at -7. So that's going to be 7, 8, 9. And I can connect this with my curve. Remember, it is going to open to the left. There you go. And that's what it looks like. Now, if you're wondering how come I'm not dealing with this +4 and this -7, I already did. So when I move to 4, -7, I've already done the +4 here and the -7 here. And now I am just doing a square root. If this had been a positive in front of the x, I would have gone to the right one and 4 and 9. But since it's a negative, I'm going to go in the negative direction, 1 and 4 and 9. Hopefully that helps you out on square root graphs.